So I'm going to demo this little app that we built internally to kind of just get more familiar as a team with kind of all of our tooling and kind of modern sort of patterns for interacting with Stacks in the context of a front-end application. So the app is called Heystack. It's kind of like decentralized Twitter, or just sort of a wall messaging app.
Thomas, can you make your font size a bit bigger or kind of maximize?
And maybe. I know you can zoom in on Zoom. So if you go to like view options, you can kind of see my whole screen as is. I know I have a huge screen. Let's see if I can zoom in a little bit.
Yeah, if you click view options, zoom ratio 100%, and then you can just drag the screen around. That's pretty helpful. I didn't know that.
Yeah, I use that all the time. But okay, so yeah, the app Heystack is using a few different elements. It's a React app, uses our Connect library. It interacts with the web extension. So that's for authentication, for signing transactions, things like that. You can kind of see too, as I was talking, someone, Patrick.btc, sent a message. It's live updating. It does not use WebSockets, but it kind of fakes sort of the real-time feel. But yeah, so I will go ahead and demo the app. You can sign in. You can select one of your accounts. I'll select this one. All the messages sort of adjusted because as the app updated, it realized that those were my messages. I will send attach a GIF to it. It'll pop up, show the transaction that we're signing, and I'll kind of go into the contract and the various methods that it has in a little bit, but the main sort of interactive functionality of the contract in the app is the send message method, which takes a string and an optional parameter for an attachment URI, which is not unlike the kind of pattern we have for the fungible token standard and non-fungible token standard, which I think we'll get into a little bit later. But in this case, it's just a link to a GIF that then the application can kind of use at a later time. We'll sign that, should confirm. There we go. Automatically shows right up. And we can go over here to our extension, see our activity. We can do it in the Explorer. Kind of see the arguments that were passed. And yeah, additionally, we can go, and there's one other kind of little bit of functionality that interacts with another method in the contract, and that's you can like a message. And for various sort of activities, whether you're sending a like or you're sending a message, you'll either send someone a token, which is related to this app called Hey, or you'll burn a token for sending a message for tweeting, basically. So yeah, this method is the like method. It takes one parameter, which is the ID of the message you want to like. And I'll sign that. And there we go. This one is a little bit less real time. So you get a toast as a message to kind of say like, hey, you know, this is going. We can go over here, see the activity again. Right here. Yeah, so that's the basic kind of functionality of the application. And now I can kind of go into some of the patterns and tools that we use to build it. I can start off with authentication. Also, forgot to say, if at any point you have any questions or I'm going too fast, please interrupt me. I would love to answer any questions and kind of dig in deeper if you need it. Yeah, so the
quick question. Can folks just try it out as well? Can I share the URL with them?
Oh, please, yeah. It's heystack.xyz. So go ahead and use it while I'm talking about it.
Is it on RegTest?
It is on RegTest, yeah. Oh. So I can go a little bit into that too before we get started. So there's mainnet, testnet, and regtest. Those are different variants of the Stacks network blockchain. Mainnet is mainnet, you know, that's where all the real stuff happens. Then there's testnet, and then there's this kind of newer one that we're still sort of like working through, but regtest. And regtest is a little bit different in the sense that it's way faster and I think my understanding is it doesn't have mining in the same way that like Testa and Mainnet does. And so it allows for like faster block time. It's like 2 minutes instead of 10 or 5, So when you're working on an app, it's really helpful. I personally don't like running a mocknet or anything locally. I prefer to use something that I can share with people. And so I'll almost always default to RegTest because it's so fast. And for everything I do, which is more front end or app specific, it has everything I need. So yeah, building an app, you need, the first step for anything is to authenticate a user.
Hey, Thomas, I'm sorry to interrupt you again, but is there
Sure.
any way to either just share the VS Code window or somehow increase the font size?
Yeah, sure. Let me stop and switch back to that. Let me do a couple of things quick. Okay, how's that? Better? Cool.
Much better.
Yeah, so the application is a React app using Create React App, pretty straightforward. It's all open source, so we can link to it afterwards as well. For state management, we opted for using this thing called Jotai, which is a Atom-based kind of state management library. If you are familiar with Recoil, it's very similar in nature to that. But these patterns will work with any state management library that you use, whether it's Redux, Mobex, ZooStand, any of the new cool stuff. Yeah, so I'll kind of go through the state for authentication a little bit. We have kind of this encapsulated piece of state called the user atom. And essentially what it's doing is, we have this concept of a user session that is kind of exported through this package Stacks Auth. If you're going to be adding authentication, you got to use this stuff. User session is essentially a class that kind of provides some useful kind of, it abstracts away kind of storage of the user data once they've authenticated and allows you to access it in a couple different ways. But for our app, we have this thing that's an atom with kind of a default value. And so what we're doing is we're getting the user session, and then we're checking to see if the user signed in. If it's signed in, we're just going to automatically kind of provide that user data. The nice thing about this is both kind of an atom that has a default value and then one that is writable too. And so let's say the user is not signed in. We can go to this component, which is basically the Connect Wallet button component, which uses another package called Connect React. And so this is React's focus. It's an opinionated library that exports some hooks for you to interact both with authentication and with signing transactions. And so kind of the main primary thing you need from this package is the use connect hook, which basically just exports all of the stuff that the user session has with some other more opinionated methods. For authentication, we use this method called doOpenAuth. And essentially what that does is when you hit the sign in button, it will check to see if the extension's installed. If it's not, it'll load up kind of that connect dialog that you might have seen if you use other apps that are directs you to the Chrome extension store or the Firefox store. Takes a couple parameters if you want. You can have it either show the dialog or you can have it go straight to the extension. But yeah, I'm just kind of wrapping this in another method so that I can add some nice loading states to it to kind of give some feedback in the app. Once that's done, the app then is kind of aware of, the user will authenticate. The extension sends a payload back to the app, which consists of a JWT token that kind of contains some information that typically isn't very useful, but sometimes it is. And then it also uses kind of that session filled in with things like the stacks addresses for both both mainnet and testnet for that account, a username if it's applicable in this context, and things like that. And the nice thing about this too is this kind of automatically updates. Once this becomes true, it'll return kind of a new session with that data. Yeah, and then we can kind of go to another hook. All the logic for kind of interacting with the extension or with the contracts are either contained kind of, in the store directory down here. We can kind of look through, and there's a bunch of state around kind of interacting with the contract and storing some data around, messages. But I can kind of dig into the main sort of functionality of sending a message in using the contract as kind of a data layer. Yeah, so we're again using this use connect hook from Connect React. And this time, instead of using do open auth, we're using do contract call. Essentially, the way that the messaging is working is in the front end, there's an input that allows someone to type some string message. And then, we have that other component that allows you to search through Giphy and find an image URL. And so what we're doing is, there's some state, basically, like set state in React that logs the value of the message. And then if they've selected a GIF, there's another kind of atom that handles that. And then ultimately, when they hit send, they're calling this handle publish content method, which is kind of a wrapper around that do contract call. And do contract call takes a few things. It takes the contract address, takes the contract name, it takes the function name, and in this case, the function name is send message. This is something that I personally like to do, where I want to essentially abstract out the addresses for the kind of primary app contract and the token contract, and then use an enum or some consts for all the various names of the methods. This method takes two parameters. It takes a string UTF-8 clarity value, and then it also takes an optional same kind of string value as the attachment. When you're interacting with a contract, you need to convert the values from standard kind of JavaScript strings or numbers or whatever they might be to clarity values. And so to do that, you would use the Stacks transactions library. And this is a great library. It kind of exports everything you need to interact, either like making transactions or interacting in some way with clarity. And you kind of see here, it exports all these methods that allow you to convert values between JavaScript and clarity. And so, this is the string CV file, which, there's 2 or 3 different kinds of strings you can use in clarity. And essentially what it's doing is, it's taking a string and then converting it to a buffer and then adding some type information that is then later read by the network. But yeah, so the do contract call takes 2 function arguments. It's an array of values, which have to be clarity values. And this one's a little bit, tricky. I think there's a lot of work we can do to maybe improve this, but it's an optional value. And so you have to wrap whatever the value is in this sum CV kind of helper method, which, I think it comes from like a functional programming kind of pattern. But in the case where, the user maybe hasn't selected a GIF, we just pass this none CV type. And without these, the contract call will fail. Additionally, you can pass a couple other methods that can be fired at certain times during the interaction, meaning, when you're done, typically you'll want to do something with that information, and onFinish actually does return a data object, which essentially is the TX ID, which is a hex string for the broadcasted transaction. that you can use to like maybe link to the Explorer. You can link, you could use it to then maybe fetch data if you want to display some like pending information. It also returns the signed transaction that the extension signed. And sometimes you might want to use that for various reasons. If you want to persist it or pull something from it, or if it's a sponsored transaction, it's really helpful. In this case, what I'm doing is pretty straightforward. I have an unfinished callback up here, and all I'm doing is disabling the loading. So it's no longer kind of showing that loading state in the button. And then additionally, this is a nice UI pattern that I think more apps should adopt, but you can kind of fire or like switch a Boolean when the user has interacted with an action, and then you could throw kind of a backdrop and a message that is saying, hey, please sign this in your extension. And then, when they've either finished or canceled the transaction, it kind of goes away. And so these are just helpful callbacks to kind of enable a better UI or UX of the application you're building. The other thing that this method is doing is it's constructing some post conditions. And so when a user likes when a user is sending a message, they're burning one of the Hey tokens. And so in any kind of contract call, whether no matter kind of what it is, if it's interacting with some sort of token or a Stacks token, it's highly recommended to always use post conditions, because post conditions are kind of like guards for the end user, and it protects them, right? And I think ideally users won't necessarily interact with things if there aren't post conditions, and it has some sort of method that kind of transfers any amount of asset. But so again, this is coming from the Stacks transactions library, and this is a method for creating a fungible post condition. And so the Hey token is a fungible token, and what this takes is the address related to the post condition. So in this context, it's the user's address. It takes a specific condition code, and there's a few different options. So you can take, essentially it's like the result of this transaction is going to mean that any sort of like one of these events will happen, meaning it's going to transfer exactly this amount, it's going to transfer at least this amount, or greater than or equal, less than or equal, stuff like that. And then it takes kind of a big int number for the amount of the asset. And then here's another kind of helper method that comes from the Stacks transactions library, and that's to create an asset, basically a representation of the asset you're transferring. And so this is used in Clarity in the network. And so this is the way of kind of converting the representation of the asset from JavaScript to Clarity. And what this takes is the asset contract address, the name of the contract that contains this asset, and then the asset name itself. And in this context, it's just Hey token and Hey token for both of those. Two other things that I do think are important. So this app is in RegTest, and you can pass the network that the app is using to the extension, so that things in the extension will kind of automatically switch over, meaning like, let's say I'm doing something on mainnet in the extension, and then I go to Heystack because I want to tweet something out. I'll hit send message, and because I'm passing the network, it'll automatically switch it to RegTest for you, and search for the contract and all that stuff automatically. And then additionally, it's important to pass the current address of the signed in user to this callback, because it might be that maybe the person signed in with like the 5th account associated with their seed phrase, and if you don't pass this, it will kind of just default to whatever account they were using last in the extension. Yeah, so that's the general sort of pattern for using kind of a contract call method. Yeah, any questions or anything I can go deeper in?
Yeah, Thomas, there was one question. Let's see. So Big Clown said, looks like you're using IntelliJ IDE, but Clarinet does not have support for that. Do you swap to VS Code when dealing with contracts? This is a question or her question.
Can you repeat that? Sorry.
I think the person was wondering if you're using VS Code for Clarity development as opposed to IntelliJ.
No, I actually don't do a lot of Clarity like writing. I do a lot of interaction with Clarity in the context of TypeScript and JavaScript. And I also, some people might not like this, but I don't use VS Code. I use WebStorm. I've been using it for years. I really like it. WebStorm doesn't have a lot of support right now for Clarity. I also think, they have kind of a suite of applications, and it'd probably be a different one. But no, I think, Clarinet is really good for Clarity development. My personal workflow, if I'm interacting with contracts, is I use the sandbox on the Explorer a lot. It's easy because typically for me, the extent that I interact with that is I more or less just have to maybe modify a contract a couple of times and redeploy it. And for me, it's the easiest way. Yeah, I hope that helps. I know there's some other tooling too that's coming out that might be really helpful. Yeah, this is more kind of TypeScript React interaction with it. Cool. Let's see. I can go over to, so this is the method for liking a message. Very similar in the sense that it's more or less identical, except we're just sort of switching out a couple things. In this context, the difference is we're using the like function instead of the send message function. We're passing an unsigned integer clarity value of the ID associated with the message we're liking. And then again, we're creating the same kind of fungible post condition in the sense that, rather than burning it, meaning, I think actually in this context of our contract, they're not burning it, but they're sending it to a treasury address, which maybe, that could be really useful for certain contracts if they want to create maybe some revenue or something like that, But yeah, just transferring one again. A little bit different, the onFinish callback. This is using a Toast library that kind of provides user feedback. So again, highly recommend using both onFinish, onCancel to kind of enable a better UX and UI for your application. Let's see what else. I can go into a couple of other things around the state now. So, I kind of walk through how you interact with the contract in the sense of signing transactions and user feedback. But another really helpful pattern I've found is, so for the feed on the website, we're not actually, like, the messages themselves aren't stored in Clarity. They're an event that happens when the transaction is confirmed. And so we're kind of faking this data layer in the sense that we're taking advantage of the APIs that are provided to construct a feed. And a common way of doing that is, so we here have an Atom, and part of the reason why I really like Jotai is there's a lot of integrations that they have. And so they combine state with things like React Query, or even you could use Redux with it if you wanted to have an integration. But this is just a query Atom that essentially takes all the functionality of React Query, if you've used that before, and encapsulates it in a state object. So the reason why, for me at least, this is really useful is it gives us things like, it handles all the refetching and kind of invalidation automatically. So if a user is using your application and maybe they've switched to a different tab and they switch back, built in, there's the functionality to kind of automatically refetch that data on when they return. And there's a lot of other things too. You can, like, part of that real-time feeling is achieved through this because you can pass an interval that automatically refetches. And so what it's doing is all of our async data that relies on the API just automatically refetches at either like a second or a couple of seconds. And so gives that really like real-time kind of feel. But there are two main kind of elements that we're using to construct the feed, and that's we're fetching transactions that have confirmed. And so what we're doing is fetching transactions associated with the app contract instead of any given user. And so, do you have a question, Alex? Okay. Yeah, so we're fetching the transactions associated with a given account. And in this context, we're fetching the actual address account. So that means we're doing like the Stacks address and then the name of the contract, because they are all, like, anytime anyone interacts with the contract itself is a participant in that transaction. And so it's like Stacking Club uses this to kind of construct a historical like view of the state of stacking by fetching all the transactions related to the POX contract and then parsing whatever data we need. So we're doing something very similar here. And we're essentially just, filtering the results of that call to any contract call transaction that is of this function name and has a status of success. I'm then kind of just mapping through this, getting the TX IDs, and then I'm actually fetching again through a different endpoint because there's some data that isn't exposed by the account transactions endpoint. Things like, the result of the transaction, if you want to like parse some clarity values, which we end up doing, you have to refetch each transaction through the transactions endpoint. And it gives you a little bit more like a verbose sort of output related to like the contract interface and stuff like that. And then the second set of transactions we care about are the pending transactions. And so this is different endpoint. And so what we're doing is we're fetching the mempool transactions, and then we have to do some manual work to kind of filter it by address and things like that, and make sure it's the same method function. Yeah, and then there's some there aren't necessarily very clean ways of parsing the results of clarity events in JavaScript, and so you have to kind of do some manual work that are like replacing certain strings to extract the maybe the index or something else you might need. Yeah, and then I can kind of go through this, Adam. So now we have the transactions and we have the pending transactions, and what this is doing is essentially mapping through each transaction. It's looking at the function arguments in the context of a pending transaction, and it parses out what the user has entered, and that allows us to kind of use that data even though the transaction hasn't confirmed yet and the result of the clarity functions haven't been broadcast or like are not available. Yeah, and then for constructing the state associated with like the like count, the contract exposes a read-only method for essentially you provided an integer index of the message that you want to know how many likes are associated with it, and it'll provide you the count of likes. And so again, we're doing a similar kind of interaction with the API in the sense that we're calling a read-only function, and this is not unlike the do contract call method that I showed earlier, where it takes a contract address, a contract name, it takes a function name, in this case it's get like count, and instead of function args, it takes read-only function arguments. And this one's a little bit different in the sense of the API. You need to pass some sender, whether that's the user or I typically, because it doesn't matter, I usually just pass the contract address. And then I'll pass in the clarity value here. Difference here is previously, for like publish hey, we're passing in the clarity value themselves, which is of basically a buffer type. Here we're passing in the clarity value that's then converted to a hex string. that then the API will kind of use in the backend to convert to buffer and supply it to the network. Then we get that data back, and that data typically, let's see if we can see the shape of it. Yeah, so it'll more or less give you an okay, and that's if it's failed and like the status of the success or not. And then if it is okay, it'll give you a result. If it's not okay, it'll give you a cause typically, and it'll be some pretty helpful information around what kind of error might have happened. But the result is a hex string clarity value. And so the transactions library, it provides some other really helpful methods for converting that hex string to something more usable. And so you'd want to, parse this with the hex to CV, so that's hex to clarity value. And then there's a few other methods you might want to use. In this case, I'm using clarity value to JSON, but there are other ones like clarity value to string and clarity value to buffer and things like that. But in this case, I want a JSON because I knew the response is a tuple, and a tuple is just basically an object. And so here we have the result. And unfortunately, one of the side effects of interacting with clarity is there's a lot of nesting. And so you essentially just need to kind of nest down to whatever value you're looking for. Let's see. I could talk a little bit. So this is a pattern that I really like to do. I essentially have some atoms here that take the network that the application is using and creates a configuration for our blockchain API client. And the blockchain API client is a TypeScript library that is automatically generated through the Stacks node API or the Stacks blockchain API repo. So it gives you kind of, TypeDoc and open API sort of schemas for all the endpoints. And so rather than having to remember all the various parameters and endpoints, I almost always use this. And I really like wrapping it in state because then it'll automatically update like the network it uses based off of the network the application's using. And I can kind of use this right in line with all my other state. And so there are a few different sort of classes that you can use, accounts, smart contract transactions. They all relate to different endpoints or categories in the API. And for most of these, I'm using either the transactions client or the account client. But there are other like blocks and burn chain and stuff like that can be useful in different contexts. Let's see what else I can talk about. That's pretty much everything to do with Clarity integration into a front-end application.
Hey, Thomas,
Yeah.
would you mind talking a little bit more about the mapping of JavaScript types to Clarity types and the helpers and sort of why it's important that you use the helpers?
Yeah, well, I mean, it'd be very hard to not use the helpers. I've dug pretty deep into like how these are made, and it saves a lot of time. But yeah, let's talk through. So there's a lot of different. Let's see if I can find all the types. Here we go. So yeah, so Clarity has all the. I don't know all the types in Clarity offhand, but essentially, like if you want to interact with if you're doing any sort of contract call or reading any public methods from a contract that take any kind of argument, it won't work unless you pass something that the Clarity kind of VM can interpret and use, and it does not interpret JavaScript. And so maybe what's useful is like, if you're interacting with the contract, you'll have to kind of like look at the methods, understand, I can pull it up. It won't be highlighted, but here's the contract. We can see the types for the various methods, and all of these types have the corresponding JavaScript helper method. And for us, kind of like I mentioned, the main things that we're using, just because it's a pretty contrived, simple app, is string UTF, but there can be some significantly more complex kind of compositions of types. And right now, it hasn't been released yet, but in an upcoming release of the API, there's been some work done for these helper methods to work a little bit better in TypeScript, where you can pass essentially an interface to them, and it'll give you a lot better kind of autocomplete and things like that. But here's another one that you kind of look at. What I'm doing here is I'm fetching the balance for a given user, and I'm interested in the Hey balance. So that's the fungible token of this app. And so per the SIP10 standard, every fungible token will export a get balance public method. It's a read-only method, which takes a principal clarity value, which it's just an address, and it'll give the balance for that address. And so this is an atom that kind of handles that automatically for me, and I'm refreshing it every 5 seconds so that I can have pretty up-to-date kind of balances to use in the application. But I'm taking the user that's currently signed in, or I'm also using this sometimes in the feed list. I can pass in an address of any given user and show their balance too. But it's principal CV, converting it to a hex, which is just the buffer kind of serialized into a string. And then the response, very similar to what I mentioned before, it's got an OK, got a result, which is of a hex value. And so I'm converting that hex to a clarity value, which in this case is an unsigned integer. And when that is returned or converted to a string, it's returned in the basic clarity syntax. So it's like a parenthesis, okay, you, and then the value of the integer. So this code here is just to do some quick inline cleanup to it, converting the clarity value to string and then cleaning it up. That's about it really. As far as you have some JavaScript values, TypeScript values, and then you pass them in to all the helper methods. Some of the more complex ones are, you can nest clarity values in a tuple. And so it's pretty straightforward. The tuple essentially takes an object of clarity values. It's important that all the names match and stuff like that. And so, that improvement I mentioned just a little bit ago with the TypeScript interfaces, that'll really help kind of when you construct JavaScript clarity values, because you'll be following a highly typed object. Yeah. Any other questions? Cool.
You guys all saw my dope GIF on Heystack. That was an incredible demo. Thanks for kind of bridging the chasm between the Clarity world and the front end world. Open up space for any more questions for Thomas.
There's a question on if Thomas can explain postconditions in a little bit more detail.
Yeah. So like I said before, postconditions are really, really important in any event or method that is interacting with a token or an asset, right? So let's take, Swapper or a decentralized exchange or something where you can convert one asset to another, or anything, that's using an asset. Essentially, you have two options. There's two modes in which you can kind of interact with. So that do contract call that I mentioned before can take another argument called postcondition mode, and you can pass a mode of allow or deny. And if you pass allow, that means it's actually not going to pay any attention to postconditions, and meaning, let's say a user is interacting with a contract that the app is passing that. There could be some nefarious kind of uses of that, in the sense that maybe the method they're calling is like, oh, I'm sending a message to this app because I want to tweet something. But in reality, it's I'm going to send all of my stacks to this other address and I'm going to take it, right? So if someone passes postcondition allow, that we can't stop that. But the default is to deny any kind of asset transfer without postconditions. So for the Heystack app, if I had passed no postconditions, but the send message method requires that one Hey token gets transferred, the transaction will fail and it won't execute correctly because I haven't essentially defined the exact kind of conditions to which this should be allowed. And so postconditions are really helpful for the end user and for apps to, it's another layer of security protection. They work for Stacks tokens, they work for fungible tokens, and they work for non-fungible tokens. The non-fungible token postcondition is a little bit different in the sense that it really only, so you can kind of think of it as like, a transaction can have many events. Like a transaction can do a bunch of things before it's complete. So it could do like, maybe I'm going to send some stacks to another address and I'm going to receive some other asset. And then I'm going to send that asset to another, third person, right? And so you'd need to define postconditions for all of those events aside from, a receiving. Postconditions only take care of kind of knowing like a sent event. And so we have no ability to kind of control what is received during a transaction. But back to the non-fungible token, it only really cares about, at the result or the end of this transaction, what's the state going to be? And that's kind of what the postcondition deals with. And so because non-fungible tokens are non-fungible, there's only one, they're unique. The two options are it's either going to be this address that's provided in the condition will have or not have it, right? Whereas both with stacks and fungible tokens, there's a lot more kind of nuance or granularity in the sense that it's going to be exactly this amount or less than or greater than or things like that. Yeah, I hope that helps. There's another question. Yeah, so how can you explain the Hey token and how you are awarding free Hey tokens upon user registration? Sure, let me share my screen again and sign out. I have to do my whole desktop because it's going to show a pop-up. But so you can sign in with a different account, one that doesn't have any Heystack. And so we can go here and we can hit Hey, claim Hey. And what that is doing is it's actually calling another method in the contract for request Hey. And then it's essentially a faucet function. Let me switch over to my IDE and we can go to the Hey token. So this is the token contract that conforms to the SIP10 trait, which means it provides methods for the name of the token, the symbol of the token, the decimals and stuff like that. We have another method that basically gifts the token to anyone. And so what this does is it's gift token and it just takes a recipient, which is of a principal type, and it mints one Hey token to that address. This method is actually implemented by the Hey app kind of contract. And so that method I showed in the app before, what it's doing is it's calling this public method, similar to the like message method or the send message method. But all this does is it takes a recipient, which is of that same principal type. And what it's doing is it's contract calling that Hey token contract, and it's calling that gift tokens and providing the recipient. Yeah, and so if you're building an app that, has an asset or needs some ability to kind of provide like liquidity to individuals, that's a good way of doing it. this one is specifically, you only get one. Hey, you could have it be more, you could have it be 10, 50, whatever. You could also, if you wanted to impose limits to it, where, maybe if they have a balance, you could call this get balance. And if they have a balance, it'll fail or won't allow them to call it, things like that.
Thomas, quick question.
Yes.
Maybe it helps to explain why there are two different Clarity contracts. And you might have some thoughts on that.
So I actually didn't work much on the Clarity contract. My coworker did, but I think there's some advantages to it. It's like separation of concerns in the sense that, the underlying functionality of the token itself isn't really going to change. Meaning, once you've kind of defined how many decimals in various uses of that token, it's good to just kind of deploy that contract because, like in my workflow, I had to redeploy the contracts a few times, but I only had to redeploy the token contract one time, whereas I redeployed the app contract like 5 or 6 times. And so, I think it's a pretty good pattern to follow of like microservices. You can kind of think of them as, like the smaller the footprint of a given contract, another contract can always implement that and use one of the methods in it, right? Plus it costs money to deploy a contract, so. Let's see, Heystack is only working on Redis. Yeah.
Yeah, there were questions about obtaining Stacks tokens on Redis. You have to go to the Explorer sandbox and then click the little water droplet that takes you to the Stacks faucet. And you need to make sure that the Explorer sandbox is set to reg test. It is not there by default. Horini from Block Survey just shared a link to the reg test API. You need to enter in a specific URL, a specific chain ID, and then like a name for it, and then it'll be populated in the Explorer sandbox. Make sure you're logged into the sandbox using that reg test address, and then you should get your Stacks tokens. I just did that 5 minutes ago. Like Tom said, it's a lot faster than the testnet and mainnet. I got my testnet Stacks in about 1 to 2 minutes. Then that allows you to claim your Hey token 1 to 2 minutes, and then I posted my message 1 to 2 minutes. Should be like 3 different transactions there to use the app.
The other thing I'm probably going to do for Heystack is just add a button to get reg test Stacks from the faucet, because there's going to be some work done on the Explorer such that it's a lot easier to interact with reg test too.
Yeah, it looks like there's going to be some big updates for the Explorer coming, specific granular URLs that can let you populate the Explorer contract deployment thing with a pre-populated contract. You can deep link into a specific contract call, stuff like that. Only more functionality to come for the sandbox.
Yeah.
Does RegTest implement micro blocks?
It is actually the current deployment of RegTest is a testing deployment of the PR in flight for microblock support. So it does. Yeah. But that's not why it's fast. It's fast just because people like the config is a little bit different.
Yeah, it mines blocks faster. For microblocks in general, the protocol level support has been there from day one, just FYI. I think what we're currently building is really the tooling surrounding it. So the API needs to expose the latest chain tip of a microblock, what kind of microblocks are currently considered part of the next mine block and all of that. We're adding those features in the API as we speak right now, and the reg test includes that PR for the API itself. But the concept of microblocks is in the Stacks network already since 2.0. Next question is there an EC recover equivalent in Clarity? I'm not familiar with EC recover.
It's essentially for getting either the public or a private key from I think that's what you're referencing, like the elliptic curve recover function. I don't know. I know Pascal, who's very prominent in the ecosystem. He's done a lot of stuff related to kind of like various types of encryption in the context of Clarity. I would maybe reach out in the Clarity channel to him. Signature validation. Yeah. I don't know.
Question on using Vue over React.
Yeah, so right now we don't have kind of like an official Vue library. There definitely are ways to do it. I can, if we have time, I can kind of go through that pretty quickly if you're interested. We might be at time, but
We've got a few minutes, and we can always have Friedger and Jude jump in as soon as this is over.
yeah, let me just pull up a new thing quick.
And it might be related, but we also have a team who's submitting a grant proposal to build a Flutter SDK. I'm sure that there's a lot of similarities with the React SDK. It might be helpful to kind of, if not only to kind of help that team scope out the project, but also to maybe publish something about what the general scope of an SDK would require for other frameworks.
So we have that Connect React SDK. It's opinionated for React, uses hooks, uses context, all that stuff. But to enable that, it's using an underlying package called Connect, and Connect is agnostic. It's not framework specific at all. It's JavaScript. So you have to do, it could be Vue, could be like Svelte, other things like that. For authentication, it exports this method called authenticate, which takes essentially the same parameters, that I kind of was showing before. And if you wanted to use this in Vue, you would more or less just implement, the authenticate, use this, call it as you please. And then for the kind of the more complex kind of transaction signing, it also exports these more or less builder methods to construct. What it's doing is it's constructing a JWT that's then passed to the extension. And so you can use these methods called make contract deploy token, make contract call token, make Stacks transfer token. What this is doing is, it takes these options, which are very similar in the sense, it takes the contract name, contract address, function arguments, basically what you would supply to the hook method that I was showing before. And it'll create a token, and then it's just a string, basically, a JWT token that then you take and you pass to this. Actually, hold on, let me double check on that. Yeah. Okay. You can use this method if you want, which is kind of a combination of two methods where it generates a token and then opens the pop-up. But if you want to do something kind of more advanced, you can kind of generate the token itself, and then you would use this method open transaction pop-up, which interacts with this provider the extension kind of passes to any application. It's very similar in nature if you've ever used like Ethereum and MetaMask, Web3, that provider that's kind of used to be passed by MetaMask. We're doing something very similar with the Stacks extension. But you would generate, the JWT and then open up the dialog through these methods. And anyone can create any kind of JavaScript sort of framework-specific implementation by using these methods.
All right. Well, thank you very much, Thomas. That was very, very helpful and very in-depth.
Yeah, thank you.